Hi, George. Hi, Joyce. We are going over some questions, some remaining questions from corrections that Kayla's had. Jackie, Gerardo, and Amanda just did 15, 17, and 18, so we'll take pictures of those if we agree with all the work, which I think we do. Once we get there, we'll post them in the group chat, but then otherwise, the other problems we'll just work out here. I already had them go through and tell me what questions they had, and so I've circled them in the exam itself, and then I told them that I will post this online in your secure shared folder. That way it's not like open to the world, so yeah, you guys can still utilize it. Because if you want the extra explanation on multiple choice questions, it does go through and give you a detail, like for number 1, which option is correct, why it's correct, and why the other ones were given, what mistake was shown in them, which is kind of cool too. Because literally for every question they have that's incorrect, they have some sort of misunderstanding that would have led to that answer, which is why it's so hard sometimes, because your little error in thinking can throw you off. And make you think that you got it right when you didn't. So let's see. The first one that no one could answer was number 13?
Yeah.
It was number 13. Okay. So the graph of a differentiable function f is shown above on the closed interval. Oop, there we go. Negative 43. How many values of x in the open interval satisfy the conclusion of the mean value theorem for f on negative 4 to 3? Okay, well, what is the conclusion of mean value theorem? I have a differentiable function, therefore it's differentiable and continuous. Mean value theorem says then there must exist some
value c,
x equals c such that
f prime of c equals the average value.
f prime of c is equal to
F
f of b minus f of a, which, what am I about to be doing?
average slope, secant line.
Okay. Now, if we had actual points, could I theoretically plug and chug for this? And the answer is
Yes.
yes. But since I don't have points, what am I going to do instead?
Guesstimate.
I would say think about the slope of the secant line, right? And then ask yourself, okay, where else would this be mimicked? I see a point, let's see, my slopes go positive, then it levels off to 0, and then negative. Somewhere around here, isn't there going to be, oops, let me get on the curve. Somewhere around here, isn't there going to be a negative slope? That's going to be parallel. That's 1. Then I go really steeply negative, and then it comes back around again, right about, let's see, that'd be positive. So right about here might be a negative, another one. I could see that. That's 2. Then it's going to go positive, and then it's going to go negative again. So I would say maybe around there. So just looking at the nature of the graph, there are going to be 3 parallel slopes of tangent lines, a maximum of 3 possible. Does that match up?
Yeah.
Does that make sense? There is no solving. It's more of a concept-y question. So the slope of the secant line, how many tangent lines would have that same slope? And the answer is 3. Tricky, 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 huh? Number 15, we have the work up on the board. So I'm just going to quickly see if I agree. They give you a function for what? Speed?
Yeah.
Okay. M is distance. What is the maximum speed? Well, whenever we want to find the maximum on a closed interval, we want to find absolute maximum, right? And so what I see and what Gerardo did is he found the derivative, which I would agree. So the derivative equal to 0, found his critical numbers at 1 and at 2, which are both in the interval 0 to 3. And so he tested the original speed at each of them and found the max speed to be at 0. But, oh, they weren't tricky on this one. It was at 0, but it was a maximum speed of 7. And I totally agree with the work, so we'll get a picture of that in the group chat. Number 17. U-sub, no. Guys, look at all the answers. Can't you tell it's an integration by parts?
No.
No? Has ln of one u and ln of another u, that means you're going to have two separate fractions with two separate denominators?
Oh, I did thumb trick.
Oh, no, but, oh, sorry, I said parts. I meant partial fractions, lo siento. My head is fuzzy.
I just wrong answer.
It just
I
didn't
did
work.
an A.
So then Jackie showed his work over here on the side. Did you do thumb trick, Jackie?
Mhm.
So plugging in -1 when you cover x or x plus 1. -1, that'd be -18 over
Wait, got
-3.
Got it.
You got that, too.
Yeah, there's because it's 2x minus 1 on the bottom, so it's ln, because, x prime.
Oh, you forgot the u prime.
Got it. I was like, I'm getting -4 every time. I don't know what I'm doing.
You were going too fast, you forgot u sub.
Yep.
Beware the u sub. We'll get a picture of that. Joyce and George. Number 18, slope of the line tangent. Slope is just a dy dx. And so for dy dx of a polar curve, Amanda went ahead up on the board and found x is our cosine theta, plugged into the derivative at what, pi?
Mhm.
And then y equals our sine theta, good, plugged in, found the derivative at pi. Plugged in both, ended up being 3/0, which is undefined. Good. And then this one ended up being b, is that right?
Oh, that one would
B.
be, yeah, that one.
I'm sorry. Yeah. Okay. All right. Number 20. As we get back to that one, steak.
Wait, I finished it off and realized like, oh, it's the same exact mistake on this type of problem.
I'll take pictures after we finish. Okay. We can say mistake. What mistake did you make?
Like the limit was 1/2, not 1. I always forget the 2 at the bottom. Or like that number there.
Okay. So how do we start? How do we get there?
Limit is n approaches infinity of x minus 5 to the n plus first power all over 2 to the n plus 1 times 2n plus 2 plus 3 quantity squared times 2n plus 3 quantity squared over x minus 5 to the n quantity to the n. And you can do your little Zola slashes.
What are you using to get this?
The formula.
Yeah, for the interval of convergence, right? And then we're setting that at less than 1, yeah? So then when you simplify, you're able to leave in absolute values your x expressions. You can pull out all of your n expressions. 2 to the n is going to reduce. This stuff is nasty, so I'll just leave it 2n plus 3 squared all over 2 times 2n plus 2, 2n plus 5 squared?
Yeah.
And then you end up with just x minus 5 in the absolute values. Oops, I just passed off the one. There we go. Okay. And as Jordan was saying a second ago, take the limit. Guys, do you actually need to FOIL out these?
No.
No. Instead, you can figure out that the first term isn't going to be 4n squared over 4n squared. So they're going to be tied except for what Jordan was saying earlier. We have an term. At which point we can go ahead and do x minus 5. We would multiply both sides by 2. We have less than 2 and greater than -2, at which point we end up with x is less than 7 and 3. My radius is equal to 4. No,
Over 2.
7 minus 3. All over 2. Final answer, C. You guys agree?
You said your thing.
Yeah. I got sick Thursday evening, beginning of spring break. And then I kind of hung in there. End of Baja trip, I started feeling a little better, and then I got home, and then it crashed again. But I think that's like what went around, because everyone got sick and then started feeling better, and then they crashed, and then they got. So hopefully this is the last round.
Big name.
Mhm.
You said last round, I said big name.
Just gotta hang in there for the last round.
Is that cat monster?
21. Did I get it right?
I did. No, I didn't get it right.
Okay, so what trick is?
D&E! Tangent does not exist at pi over 2.
Because, if you're noticing what weird is going on, if we tried to solve, integral of secant squared is easy, that's tangent of x, tangent of pi minus tangent of 0, but what we wouldn't have considered is that we need to split the integral up at pi over 2, because we have an asymptote.
That's mean. Evil.
We have an asymptote at pi over 2 of tangent is sine over cosine, secant is 1 over cosine. Cosine is going to equal 0 at pi over 2. So improper integral is basically what's going on. We need to split up at pi over 2, and as we would integrate at pi over 2, tangent of pi over 2 ends up being d. The tricky part of this one is the integral equaling 2/3 doesn't make any sense. And then secant squared, just because the limit of secant squared doesn't exist doesn't necessarily mean that the integral won't exist. Remember, improper integrals, there are some that look to be infinite and they're truly finite. So we are thinking about the integrand because we're thinking about solving the improper integral. In my head, I actually would have gotten a little bit stuck between A and D. George actually asked me this one as we were driving back from Baja. Because letter A, I was thinking of tangent. Oh,
Yeah,
that's the problem. I was thinking of tangent.
Oh.
Tangent area above and area below are equal, they cancel each other out, but we're not taking the area of tangent, we're taking the area of secant squared.
I read that one wrong then too.
There we go. Did you think it was A?
Yeah.
I was thinking of tangent's area. Struggle. Get out. I was like, I'll think about that when we get back in class. But the letter D, it makes sense because when you try to do FTC, you try to take the limit towards the bound. Yeah, you're gonna get D. Okay. What do you guys think about the 4 answer choices instead of 5?
Oh, I like it.
Okay.
It means
Well,
I have.
29 was the one that I did.
I mean, that 25% chance of getting it right, but a 75% chance of getting it wrong. I like those odds.
No, that's a little better than 20. I'm not sure if it really makes a huge difference. I feel like there's not as many like DNEs or nuns. You know what I mean?
Yeah.
Like there really isn't that many nuns. I'm not sure if that's gonna make the curve harder. I don't know. Alright, number 27. What's going on? Graph of F. Ooh, this is an accumulation function, so G equaling integral. G needs to be negative and decreasing. This is F. Okay, in order for G to be negative, what has to be true?
G prime has to be.
For decreasing, yeah. G prime, which is equal to F of X, is going to be negative. So right away we know that that's only true for, we're doing negative 2 to 2. Okay. So X greater than negative 2 and less than 1. So anything that goes above 1 is an automatic out, which that's only letter D. But we also need G to be negative. Now, question. What's the lower bound?
0.
So, if we were thinking about this area right here from 0 to 1, that would be moving normally, right? So from 0 to x of f of t dt is going to be less than 0 for x within 0 to 1. Open. Because you're moving the normal direction, you're moving from left to right, lower bound to upper bound, and it's below. So that's good. Why is it not good once we go the other direction?
Because it's
Yeah,
negative,
that's
negative.
negative in front of it.
Exactly. Because if you were to go the other direction from 0 to x, that'd be the same thing as negative x to 0, right? Of f of t to t. And a negative times the negative area is going to actually end up being positive 4x within negative 2 to 0. So that's why we're only able to choose letter C. Does that C? Does that make sense, everybody?
Just write it down.
Yeah, it's all about which way you head. If you head from a lower to an upper, you can just keep it like, hey, the area is negative. If you go from an upper to a lower, you're backwards, the sign flips. Ooh, logistic. Go team. Okay, how did you guys try rearranging this logistic growth differential equation?
Plot the 850.
Okay. If you pull out the 1 out of 850, you end up with n prime is equal to 1 over 8500. N, there's our kn, right? Then we're going to have 850 minus n. So we have our kn times L minus n. So what's our limiting constant?
850.
Which one is false? The limit as t goes to infinity is 850. No, that's very true. That's the limiting constant.
So,
dn dt has a maximum value. That means the rate is maximum when n equals 105. Why?
Because it's gonna be when
Yes.
n is 420.
This is so
Yeah,
long.
425.
So you're going to have n equals L over 2 is the max, right?
Yeah.
Which is going to be 425. Which is exactly.
Excuse me.
Is that true? Exactly.
Oh, yes.
He's calling for them. But for letter C, the second derivative is a point of inflection, which is why that's true. And n above that point,
Didn't they give you the? Didn't they give you?
the
Didn't they
rate is
show you?
positive. Yeah, the
show you
slope
the
is
picture
positive,
for the-
but decreasing. Yeah,
for
so
the-
D is true too. Does that make sense, guys? Okay, cool. That'd be the max.
I read which is true.
Oh, it's so easy to do on these.
This
I
one,
was
I don't
reading-
even know what this is saying whatsoever.
29?
Yeah.
Yeah.
This was the one I was thinking of that I figured everyone probably missed.
Yeah, I just
This is the definition of the integral.
we need to really practice that, 'cause that always kills us every time.
Well, the problem is it's
Isn't
never
it
actually been
that
tested
was
before
the
that I
first-
knew of. But they're getting more concepty this year, so they threw it in.
Wait.
Is equal to the area. Well, you guys know the limit and then goes to infinity, but the struggle is they all have that. 3 over n.
You know what I just realized this, dude?
Why does 3 over n make sense?
Oh, shoot.
Why am I going to cross out both of those? Think of Riemann sums. Because you're doing basis times height, but you're making the number of rectangles approach infinity, right?
Yes.
Infinitesimally thin even between 1 and 4. If I did base, wouldn't I need to think about delta x?
Mm-hmm.
And wouldn't base be 4 minus 1,
Okay.
the distance cut into n pieces?
Yeah.
Does that make sense? So it's like a Riemann sum. That's how you know it's 3 over n.
Okay.
So right now we have a and b. And then for heights, how do we find heights? I think this is a perfect one. So we do f of x star values, which we could come from the left, we could come from the right, we could come from the middle. But the long story short is, do we want 1 plus ln if the function is ln, or do we want ln of?
More on.
We need a function value, that'd be ln of. Letter A is not really, it's like 1 plus a function value, that doesn't make sense. And we need our base to be 3 over n, we need that distance of 3. They did 4 over n because they were trying to trick people, going from 0 to 4 is my guess instead of 1 to 4. Just using the 4 and not thinking about the distance between. So it basically is a Riemann sum, just which one is a proper Riemann sum that you could actually use, and then just think we're making the widths be infinitesimally thin. That's basically what's going on. Does that make sense, kind of?
You know, it makes you think. Integrals are like so easy now, but like it's so much harder. The definition of integral is so much harder than a definition of
Oh yeah, so much better.
Like, how did they figure out that it's just a change in an
Because you have to actually express the summation as a function, and then take the limit.
Mm-hmm.
That's much better.
How did they figure out it's just a change in an attitude?
Fundamental theory of calculus is why it's so important, and yet so crazy all at the same time. They all came back to MDT though, right? The fundamental theorem is proved by the entire theory.
Yes. Yeah, the answer is yes.
I showed that once by the time. Because you can split the big subinterval down into smaller subintervals. Technically infinite in some ways. And then for each smaller subinterval, you can say that NBT applies. And so there's a special value where the average is equal to instantaneous. And then it just goes from there.
Yep.
Oh, we're right there. How many more do we have? Number 80 is a polar area. I would need to get this on my graphing calculator, so can we come back to that one tomorrow?
Okay.
Do you need a calculator for this one?
No, 90.
87.
87.
You just have to think of your differential notation. F prime of P is equal to D F D P, right?
Right.
What is F measured in?
Time.
Hours.
Hours.
And what is P measured in? Yep. Hours per PSI.
It's just weird because we're used to it being like PSI per hour.
Yeah. Yeah. So they're just trying to trick people.
Me and Reeves were talking about this afterward, like hours per PSI. We're both joking about it.
Kyle Bowie is like, oh, I can't believe it. Like I chose
That's
something. He ended up being right.
ridiculous. Function models mountain. So it's hour.
So we're trying to think of what's going on at -4.
For this one, the reason why I didn't get it is I was doing since the bigger converges, the smaller converges. But that's not true. Okay. Is it that way?
My thought was,
You guys are early. Oh, is it really yet?
my thought was, well, since we don't know a sub n, we can't really tell if it's never been a -4 conditionally. Because like, it might have the a sub n might have a -1 component to it. But
So before the n, a sub n?
we don't know if a sub n has an alternator. So,
There it is. So the problem is if a sub n has an alternator, then the other alternator might cancel it out, right?
yeah.
That's the dilemma.
Yeah.
Convergence conditionally. Well, convergence conditionally kind of includes them into that anyway, right?
Yeah, it means that there has to be an alternator in a
There
sub
has to be an alternator in a sub n in order to converge conditionally, not absolutely. Yeah. So the final one would be?
C.
Since there's an alternator, another alternator, they would cancel each other out. That's classic. Alright, cool kids. We'll go ahead and keep on going tomorrow, but I think we got the majority of them done. But if you want to go peek at the answer key online in your shared folder, that might help out.
Taking my quiz.